Hello guys, welcome back to my channel HK Official. Today I am taking SME unit number 1. SME is nothing but Systems and Mechanical Engineering subject. So unit number 1 we are going to see in this video. I'll be covering it in one shot. So this will be very easy for you to understand and as well as you can revise it for your exam paper. So this unit is introduction of energy sources and conversions. So I will be covering each and every concept with animations I have taken. So you will be better understanding each and every concept. So let's get started with our unit number 1 of SME. The very first topic is what is energy. Energy is the capacity to do work. Energy is measured in Newton meter or joules. These all we have studied in our lower classes. Energy can be classified into two types, internal and external energy. The question arises in our paper, that is what is energy, and give grades of energy. So there are two grades of energy, that is high grade and low grade. What is high grade energy? So high grade is that form of energy which completely converts into some other forms like electrical energy, which can be converted into thermal energy. So we can convert one form of energy to the other form very easily. That type of energy is high grade energy. So for example, here I have written for electrical energy is converted into thermal energy. This conversion is possible easily, so it is high grade energy. When this conversion is not possible or it is not easy, that energy is called as low grade energy. Let's see its definition. Low grade energy will not be able to convert into other forms completely, like thermal energy used in thermal power plants to convert into electricity. I hope you are getting the concept. Now, renewable energy sources and non-renewable energy sources. This difference is also asked sometimes in the exam paper. So this is also a very important question. You must focus on this. So what are renewable energy sources? We all know renewable are also called as non-conventional energy sources, and non-renewable are also called as conventional energy sources. So first let us focus on renewable energy sources. So renewable energy sources are those which are available in nature and are used again and again. So I will give you a short trick to remember what is renewable or non-conventional energy source, that is sunlight. If we remember sunlight, it is available in nature and we can use it again and again. So while you are writing about renewable energy sources, keep in mind you are writing about sunlight, or you can say solar energy. Okay, so renewable energy sources are those which are available in nature and are used again and again. These are also known as non-conventional energy sources. The different energy sources are solar energy, wind energy, tidal energy. So these are examples for renewable energy source. Alright, we can see advantages and disadvantages. So what are advantages here in renewable energy sources? A first one is they are widely used. Then they are non-polluting, no maintenance cost. Then disadvantages, their collection is very expensive. Like solar energy, we need to have solar panels, so that is costly. Available is periodic and uncertain. That means we are available with the sunlight only during daytime. We don't get it at night time. So that is availability which is periodic and uncertain. Then power plant using these energies have low efficiency. These are disadvantages. Now let us see what are non-renewable energy sources. Non-renewable energy sources are those which can't be used again and again and can't recovered. So the trick for this to remember, keep coal, that is thermal. We use coal power plant, okay, to get thermal heat, and then impinging on turbine and all, we'll get electricity. So while writing about non-renewable, focus on coal. Coal is exhaustible, right? So this is the thing which can't be recovered, and once it is used, it will not be come back, like that thing. Okay, so non renewable energy sources are those which can't be used again and again and can't recover. These are also known as conventional energy sources. The different energy sources are thermal energy, that means energy obtained from coal, oil and all. Then nuclear energy is there, energy obtained from nuclear fuels. Then advantages is less initial cost and high efficiency. Disadvantages is high running cost, high maintenance cost, and are polluting. Okay, now let us see some difference which we have to write in our exams majorly. So renewable and non-renewable, some parameters I have written and some differences I have mentioned. So first parameter is efficiency. Renewable has less efficiency, non-renewable has high efficiency. Then running cost is less in renewable and high in non-renewable. Then initial cost is high in renewable and less in non-renewable. Here renewable is non-conventional and non-renewable is conventional. Remember that. Air pollution is there in non-renewable. So we will write non-polluting in renewable and polluting in non-renewable. Let us see some more parameters here. So this I have written for high grade energy and low grade energy. So this type of question is also asked. So I have mentioned this also. So for high grade and low grade, conversion into other form is the very first parameter. So that is completely converts into some other forms, that is high grade, and not completely converts into some other forms is low grade energy. Okay, then cost parameter, cost, high grade has more expensive and low grade is less expensive. Okay, then process of conversion, easy to convert into other form and difficult to convert into other form. Then pollution, high grade is less polluting and low grade is more polluting. Then efficiency, high grade energy has high efficiency, low grade energy has less efficiency. Examples for high grade we can see electrical energy, wind energy and work, etc. Then low grade energy, heat produces because of combustion, fusion and fission reactions. So this difference you can consider, and you can read it twice or thrice, so you will be understanding it better. So this will be easy for you to remember in exams. Then the very first topic, that is the main topic we will come upon, that is first power plant which we are going to see, that is hydroelectric power plant. Okay, so this is the diagram for hydroelectric power plant. First let us know what is its principle. So for generating electricity using water, initially what happens, we know what is there in water, if it is at place or it is stored, potential energy is there. So this potential energy of water stored at height, we know that dams are constructed at height. So this potential energy of water stored at height is converted into kinetic energy. How? When water is flowing through penstock. Now you will say what is this penstock? So you will see in the diagram, that is penstock is there, which is used to supply water from dam to the turbine. So this is penstock. So when water is flowing through penstock, by the virtue of gravity, this kinetic energy in water is converted into mechanical power, that is rotational energy. Here rotational energy is done inside turbine, and this rotational energy when provided to the generator, electricity is said to be generated. I hope you are getting the concept easily. First, what is happening here? The water is present in the dam or reservoir, and here you can see a trash rack. What is trash rack? Trash rack is used for filtering the water. As stones, pebble and all are present inside the water, they should not come inside in the system. So we are using trash rack over there, which is filtering the water. And dam gate is there, we all have seen dam gates. So this opening and closing gate is there, and then we can see if this gate is open, then water will flow into the penstock, and as it's flowing through the penstock, kinetic energy will be getting to the water, and that is given to the turbine. Turbine is coupled with the generator, and hence the electricity is produced inside the generator, and it is given through the transmission lines. So this is nothing but the hydroelectric power plant. You have to explain this. This diagram is very important. You have to draw this diagram in exam, otherwise half marks of your questions answer will be deleted. Okay, so this is very important. Then you can I will explain you more about the constructional elements, how you have to write in exams. I have written and I have made the notes like that only, so you'll be very easily familiar with it. See, this is the animation which I am displaying. See, you can see intake of water, then penstock is there through which the water is passing, and then turbine. At turbine, you can see that turbine is coupled with the generator, and electricity is producing, and that electricity is given through the transmission lines. I hope this is making very clear concept. Okay, let's go ahead. So what is introduction? Then how you have to write your answer. First you have to write introduction after diagram. Okay, first you have to make your diagram, then write introduction, like hydraulic power plant utilizes potential energy of water to move hydraulic turbine. Then hydraulic turbines are coupled to electric generators. Then you have to write principle of operation in short, like in hydroelectric power plant, the potential energy of water is used to move the hydraulic turbine, which in turn runs on electric generator to convert the mechanical energy of turbine into electric energy. Then in construction, how you have to write construction? You have to just mention one constructional element and write its working. You don't have to write the working of whole hydroelectric power plant. This will not give you marks. What will give you marks? You have to mention each component or each constructional element and write its working. May you are not getting full constructional elements and you are not getting the time of writing whole constructional elements, this would be considered better if you are writing the working as well. Okay, so construction is there. So first we will write reservoir. So a reservoir is provided to store water during rainy season and supplies the same throughout. The water from reservoir is used run the hydraulic turbine. All right, then second is dam. A dam is constructed at a considerable height across the river. Its function is to provide working head of water for power plant. It also used to increase the storage capacity of reservoir. Then trash rack. What is trash rack? I have told you. Trash rack is used to filter water. So it is made of steel bars. It is provided to prevent entry of any debris into the dam, any debris into the penstock, block the penstock or damage the turbine rotor. Then gate is there. Gate is provided for controlling the flow of water from reservoir to hydraulic turbine through penstock. Then we have surge tank. Now you will be new with this term, that is surge tank. See, the function of surge tank is to protect the penstock because of variation of flow or the velocity of water. Because the velocity of water, when we open the dam, when we open the gates of the dam, what happens? Water comes inside the penstock very rapidly. This can cause the squeezing of penstock. Okay, so for getting rid of that squeezing of penstock, we use surge tank. Here water is available. This will provide water inside the penstock and this will help not to squeeze the penstock. Okay, so this is the function of a surge tank. It is used to protect the penstock because of the variation of flow or velocity of water. Then what is penstock? You can mention like it carries the water from reservoir to turbine house. It is made of concrete to withstand high pressure, having 1 meter to 2 meter diameter. Okay, then we can mention about powerhouse. It consists of hydraulic and electric equipments. In this, kinetic energy of water is converted into electrical energy. Usually powerhouse is located underground. Then what is hydraulic turbine? That means the turbine which we are using here, what are its working advantages, disadvantages, we will see. So these are used to convert kinetic energy of water into mechanical energy. How it works? So the first you can write, water from reservoir flows through penstock to hydraulic turbine. This high velocity jet of water strikes on the hydraulic turbine, hence kinetic energy of water is converted to mechanical energy. Hydraulic turbine is connected to electric generator which converts mechanical energy into electrical energy. This is how the turbine works. Then advantages. First, the power generation cost per unit is less. Then more reliable. Starting and stopping of these plants takes short time as compared to steam and nuclear plants. Then high life. Then water is easily and readily available, less running cost, no fuel is to be burned to generate power. Then there is no problem of disposal of ash, emission of polluting gases as there happens in thermal power plants and all. So no coal is we are using over here, so no ash handling, emission and of polluting gases. These all things are not there. So this is also an advantage for using hydroelectric power plant for generation of electricity. Then what are its disadvantages? So initial cost of plant is very high. Time required for setup of plant is more. Then power generation is depend on the quantity of water available. These are located far away from load center which requires long transmission lines and these cost of transmission lines are high. So these are the disadvantages of hydroelectric power plant. Okay, then we can mention some like Mulchi Dam in Maharashtra, Koina, then Sri Sailam Dam in Andhra Pradesh, Sardar Sarovar in Gujarat. These are all examples of hydroelectric power plant. So this is how you can write. You can make it more short while writing in exam. You can make diagram, then introduce what you are writing about hydroelectric power plant for here. Then you can write principle, and in working you have to write constructional elements and their working. Maybe you are not completing the whole constructional elements, write the main one. And at last you have to mention advantages and disadvantages. So your answer will be considered as complete and you will definitely get the full marks for it. So this is the whole procedure of writing the questions answer in exam I'm telling you. Okay, so at last you can mention this example if you are getting time. And so this is the final answer for hydroelectric power plant. Let us go ahead. Now we have thermal or steam power plant. So here we have this diagram of thermal power plant. So here you can understand the diagram by seeing the diagram, that in thermal power plant combustion of substances is done. So this combustion is done in a chamber called boiler. You can see the boiler on the left top. Okay, so inside this boiler, high heat generated due to combustion enables steam formation of water, and this steam passing through the nozzle is impinged on the turbine. Alright, at this point of time, kinetic energy of steam is converted into mechanical power. Therefore, turbine starts rotating, and this turbine having rotational energy, when coupled with generator, mechanical power is converted into electrical energy. This is what the nothing but the principle of thermal power plant. How does it works? You can see different constructional elements present in this diagram. You can see coal is there, which is not seen in this diagram, but you have coal handling plant as well, which is continuously supplying coal towards the boiler. Then you have condenser, then you have steam turbine, then feed pump is there. So here what is happening, simply cold water from the reservoir is taken inside the condenser. Okay, from condenser that water flows into the feed pump. What does this feed pump do? It gives the water that velocity to flow towards the boiler. In boiler, what is happening, all whatever the coal is burning outside, its steam is provided inside this. That means all burning gases and all are provided in the boiler, and that steam converts water inside into steam, and that steam is given to the steam turbine. And now as steam turbine is coupled with the generator, electricity is produced, and again that heat or steam, we can say, it is given to the condenser, and that condenser, what does it do? It makes it again into the water, that steam again into water, and that is again given to the reservoir. So like this whole cycle works for thermal or steam power plant. I hope you understand this diagram. This is a animation which you can see here. Turbine is there, here river is there, and you can see the boiler. How it works, you can see steam is impinged upon the turbine, and that is coupled with the generator. This is how the steam or thermal power plant actually works. Now, how to write the answer, the main important thing here. So first we would write the principle in short. Thermal or steam power plant uses steam to produce electrical power. In hydro, water is used. All right, here in this, chemical energy of fuel is used to convert water into steam in the high pressure boilers. Okay, the boiler is the main part in thermal power plant, remember. Now in construction, you will first mention boiler. Boiler is used to convert water into high pressure and high temperature steam. Okay, for this conversion, the water is supplied to the boiler by feed pump, as I have shown you in the diagram. For better efficiency of plant, boiler consists of superheater and economizer. Now what does this superheater do? You know, whatever steam we are getting out of the boiler, that steam is impinged inside the superheater, and whatever water droplets or vapors are still present in that steam, so that is given out by the superheater, and only the steam which is present is impinged on the turbine for getting electricity. And economizer is present prior to the boiler. That means before the water is impinging inside the boiler, that water is given to the economizer. That economizer heat somewhat of the water, and that heated water is then given to the boiler, so that boiler will convert it into steam more easily. Okay, so this is how for more better efficiency, it can also contain superheater and economizer. Then we have steam turbine. High pressure and temperature steam from boiler is passed into the steam turbine. Then because of high pressure and temperature, steam shaft of turbine rotates. After this, the steam is exhausted to the condenser. And then condenser, what does it do? It again converts the steam into water. Then generator. So the shaft of steam turbine is coupled to the shaft of generator. The mechanical energy of steam turbine is converted into electrical energy. Then we have condenser. Steam exhausted from the steam turbine is collected into the condenser. In condenser, steam is condensed using cooling water. The condensed amount of water is known as condensate. See, if you have understand the diagram, the whole further things like working principle, whatever advantages disadvantages, you can write in your own words also. I'm just giving importance to the diagram. So if you know the diagram, if you know the working, you can write any constructional elements working in the paper. So first try to understand the diagram, and then you will get the again the further things very easier. Okay, now here is the feed pump. I have told you feed pump is used to supply the condensate from the condenser to the boiler. This condensate is already slightly hot, hence there is less amount of heat required to convert condensate into the steam. Then now let us see what is the working in short. So in the boiler, high amount of heat is generated because of burning of coal. Now the water from reservoir enters into boiler. Because of high heat inside the boiler, water is converted into the steam. Alright. This high pressure and high temperature steam enters into the steam turbine and used to rotate the turbine. The shaft of the turbine is coupled with the shaft of generator, and hence the mechanical energy of steam turbine is converted into electrical energy. If you are mentioning all constructional elements working, then it is not compulsory for you to write this working. Okay, so for just understanding, you can read this working and you can make your answer in words. Then we have advantages and disadvantages. Everything have its advantages as well as disadvantages. So what are advantages in thermal power plant? The fuel used in the boiler is coal. It is cheaper, the less initial cost, so it requires less space. Then these plants can be located near the load center, and as they are near load center, it reduces the cost of transmission. Then disadvantages: high maintenance cost, then time required for setup of plant is more. Handling of coal and ash is major problem. Large amount of water is required. Burning of coal pollutes the atmosphere. Low efficiency. Okay. Then thermal power plants example are written here. You can take Panipat thermal power plant in Maharashtra, Guru Gobind Singh super thermal power plant in Punjab, then Ikalahar thermal power plant in Nashik, Maharashtra. Okay. So you can consider these examples as well. So here we have done with the thermal power plant. The third power plant which we are going to see is nuclear power plant. So here you can see the diagram of nuclear power plant, where you can understand that only here the difference is of nuclear reactor and heat exchanger. Okay, what is happening over here, just instead of boiler which we have used in the thermal power plant, here we are using heat exchanger and nuclear reactor. So what would be its principle? Let us see. So here a reaction takes place between neutron and uranium. That means a uranium on uranium atom, a neutron is bombarded on its atom. So what happens? Fission reaction takes place, and after this fission reaction, krypton and barium and 3 neutrons plus 200 mega electron volt of energy is produced. You can write this equation as well in your principle. So what is happening majorly in this nuclear power plant is when fission reaction is carried out using this radioactive element like uranium I have taken, so large amount of energy is generated. Then this heat energy from nuclear reactor is exchanged with water in heat exchanger. You are getting the concept. The heat energy from nuclear reactor is exchanged with water in heat exchanger, thereby converting water into steam. Now steam from heat exchanger is made to impinge upon turbine blades of reaction, turbine which rotates the generator, and thus heat energy is converted into mechanical power. As the turbine rotates, it is coupled to alternator which generates electricity. Now don't confuse between alternator and generator, both are the same thing. We can call alternator as well as generator. Okay, so this is how the electricity is produced by using nuclear power plant. Here in this diagram you can see nuclear reactor is there, heat exchanger is present, reaction turbine is there, generator, feed water pump, coolant, condenser, all these things are present, right? So you can consider cold water is going inside the condenser. So some what inside the condenser, the water gets heated up. Then it is going through the feed pump. That feed pump is letting that water to get impinged inside the heat exchanger. Now stop here. What is happening on the other side? Here in nuclear reactor, that fission reaction is taking place continuously and heat is generated. That heat is given inside the heat exchanger, and simultaneously heat and water are getting mixed. So what would be the output? Steam is going to be produced. So this steam is impinged upon the steam turbine, and which is coupled with generator. We are getting electricity. This is the short working of nuclear power plant. This is only what you have to write in your paper. Let us see what is further. Here is nuclear reactor diagram. What is there in nuclear reactor majorly? So here it consists of reactor, you can say. Reactor is there, then pressure vessel is there, fuel rods, moderator, reflector, all these things you can see in this nuclear reactor. What is happening? So it is an isolated system. You can you know that nuclear reactor is the isolated system inside which nuclear fission reaction is carried out. This fission reaction generates large amount of heat which is transferred to the coolant, and this coolant when is circulated through heat exchanger, heat of coolant is dissipated to water. In this way process of heat exchange is carried out. This is nothing but the working of nuclear reactor. You can see different like constructional elements in these also. So you can see fuel rods first of all. So these fuel rods which are present at the core of nuclear reactor, you can see that at the core of nuclear reactor for fission reaction to take place, this nuclear fuel is placed inside the in the form of long cylinders bound together. So this fuel rods, inside this fuel rods nuclear fuel is placed inside to in the form of long cylinders bound together. Okay, then we have moderator. You can see the moderator. When nuclear power plant is to be started initially na, then single neutron is bombarded on nucleus of enriched uranium. After this process, a reaction takes place spontaneously, emitting three neutrons with large amount of energy at a time and leaving behind krypton and barium as byproduct. Okay, krypton and barium as the byproduct, remember. The neutrons emitted as the product of nuclear reaction, they possess high speed. Now, to utilize those neutrons for further reaction to take place, moderators are used for lowering the speed of high speed neutrons. I hope you are getting the concept. These moderators are used for lowering the speed of high speed neutrons. For example, if you want to know moderators, graphite is used as the moderator. Okay, then you have reflector, bricks like structure you can see. So here the neutrons which skip from moderator interface are then reflected back into the core of the nuclear reactor using this reflector. So reflector does not allow any neutron to skip the system. Now you have pressure vessel. Outside the reflector, a metal lining is provided which helps in withstanding the large amount of pressures generated by chain reaction. This pressure vessel does not allow nuclear core to explore due to the large amount of energy emitted spontaneously by chain reaction. Alright, now here it is concrete shielding. What is concrete shielding now? So it is a basic building block of nuclear reactor which supports the reactor and also covers the entire system of reactor so that it is isolated from the outside environment. Okay, now heat exchanger is present. What heat exchanger does in the previous diagram, so you can see as nuclear elements are hazardous to living beings, it should not come in contact with any of the elements so used for generating power. So as to carry out this function, heat exchanger utilizes. I know it is not present in this diagram, but whatever steam is going from this nuclear reactor, it is going to impinge inside the heat exchanger. So we must know what is heat exchanger as well. So as to carry out this function, heat exchanger utilizes this coolant to transfer heat to water to convert it into steam. Coolant accepts large amount of heat at the core of nuclear reactor, and inside the heat exchanger coolant flows through various tubes as these tubes are in constant contact with water, and it is easier for heat exchange to take place. Alright, so this was all about this nuclear reactor. So here you can see the animation of this nuclear power plant. Here you can see the nuclear reactor is there, and here turbine, generator, condenser, all these things are present. Here heat exchanger is also there. I hope you can get it. Condenser is there from which the water we are taking inside, and that is steam generator. Here you can see, you can consider it as heat exchanger. Here inside the nuclear reactor, reaction vessel, reaction is taking place continuously. Heat is going inside the heat exchanger, and water and heat are mixing up through which the steam is generated, and it is that steam is impinged on turbine which is coupled to generator, and you will get the electricity. So this is the concept of nuclear power plant. Now you can write the principle, then construction. I have explained you this construction and elements of elements, so you can take the help of notes for your revision. I'll read out principle, construction for you. What is principle? Uranium-235 is used as a fuel in nuclear power plant. Then the heat generated in reactor core because of fission reaction of uranium is used to produce steam. This steam is used to rotate the steam turbine. Then nuclear reactor. Nuclear reactor is an apparatus in which heat is produced because of nuclear fission chain reaction. Then whatever following points we have, I have explained you, so you can read it out. Moderator, I have shown you. Control rods, what are these control rods? I have shown. What fuel rod, you can consider them. Then concrete shielding is there. Then you have coolant. Coolant is nothing but which flows around the reactor core, and it is used to absorb large amount of heat produced. Then heat exchanger is there. Then steam turbine. You can write this if you have understood the diagram very well. If you are still not getting the diagram, go behind and see what I have explained again. So you'll be getting the concept very easily, and you'll be writing everything, I'm sure. So generator, condenser, you can consist. Now here working is there. Again, can I read this working? Okay, I'll read. So because of fission reaction of uranium-235, high amount of heat generated in the reactor. The coolant from the coolant pump enters into the reactor. Because of this, the temperature of coolant increases and it becomes hot. Hot coolant then enters into the HX, then heat exchanger. Okay, HX is nothing but heat exchanger. So the hot coolant then enters into heat exchanger. Then at the same time, the feed water is also enters into the heat exchanger, and in the heat exchanger, the hot coolant transfers its heat to the feed water. As a result of this, water is converted into steam, and this steam enters into the steam turbine and used to rotate turbine. The shaft of the turbine is coupled with the shaft of generator. Some advantages and disadvantages are also there. You can read out and you will get it well. Okay, let us go ahead. These are some nuclear power plants in India: Rana Pratap Sagar in Rajasthan, Kalpakam in Uttar Pradesh, Narora in Uttar Pradesh, Kaiga in Karnataka. So these are all examples. Now let us come to our fourth power plant, that is solar power plant. We all know what is solar energy. It is non-conventional source of energy which is available in abundance. Okay. Now I will explain you the principle in short. What is happening? Sunlight which is there, it contains photons, right? So these photons are collected using solar collectors in photovoltaic cells. You can see flat plate collector is there on which the solar energy is trapped. So these photons are collected using solar collectors in the PV cells, that is photovoltaic cells. These photons are charged particles. Remember, these photons are charged particles, and when these are collected, electrons present in the system becomes charged. When excitation phase of electron is attained, they change their band of energy. That means from lower band they try to go on to the high excited band. So they change their band of energy and travel in higher band of energy. Thus when electron tend to travel continuously, we say it as the current is formed. Hence electricity generation takes place. So this is how the solar power plant works. Now if you have understand the nuclear power plant, this diagram is very easy for you to understand. See, the right hand side till heat exchanger, it is very similar to that of nuclear power plant. Okay, so here only the difference is that where nuclear reactor was present in the nuclear power plant and where boiler was present in thermal power plant, here the only thing is changed to flat plate collector. Okay, so here only this you have to mention for flat plate collector, and the whole diagram is same as we have seen before. I'll explain you. See, cold water is taken from here and that is given to feed pump. Okay, then from feed pump it is given to the heat exchanger. Now stop here. Now you will get heat from flat plate collector. How? As this solar energy is trapped in photovoltaic cells, as I told you, these photons are charged particles. So when these are collected, electrons present in system becomes charged, and when excitation of phase of electron is attained, they change their band. And as they change their band, as electrons are moving, what we call that electrons movement, flow of electrons, is electricity. So thus electron tend to travel continuously and we say current is formed. So this is given to the heat exchanger and the steam will be formed, and that steam is given to steam turbine, and hence from generator electricity is produced. So this is nothing but the description for diagram. Now let us see what we have to write in this introduction. Solar energy has greatest potential of all sources of renewable energy. The solar energy is largely available in our country. Why? Because sunlight is abundantly available and it is not exhaustible. Then the main difficulty in using this energy is its collection and storage. Can we store sunlights anywhere in any container and all? No. So this is the very main difficulty in using this energy. Then we have in construction, there are two types, like flat plate collector is there and parabolic plate collectors are present. So what happens, why we use flat plate collectors? So these collectors are used for generating temperatures below 100 degrees Celsius, and parabolic ones are used when temperature is above 100 degree or 200 degrees Celsius to be attained using solar collectors. Okay, and the parabolic type surfaces are used which reflect and converge. You can imagine the parabola. So here what will happen, reflection and conversion of radiation at single point takes place, and this generates large temperature concentration of solar radiation. Okay, so in flat plate collectors, here as it is written, flat plate collectors are used for collecting solar energy. These are made in rectangular panels. These are simple to construct and it consists of transparent cover and absorbing surface. Insulation is also used, in which you can mention like insulation is used to prevent the loss of heat. Then the commonly used insulating material is fiber. Then heat exchanger is there, the same thing you can mention, like heat exchanger is used to exchange the heat. Heat exchanger, heat absorbs by coolant from flat plate collectors is transferred to water, and because of high temperature of coolant, water is converted into steam. Steam turbine, what it does you all know. So then read if you want. Generator, we all now familiar with these concepts, and we can write in our own words also. Condenser is there. Now let us see the working in short. The solar rays falls on the absorbing surface of flat plate collector. The absorbing surface absorbs the solar radiation energy. This energy is converted into heat and water flowing through the tube gets heated. The coolant from the coolant pump enters into the reactor. Because of this, the temperature of coolant increases and it becomes hot. The hot coolant then enters into heat exchanger. At the same time, the feed water is also entered into the heat exchanger. In the heat exchanger, the hot coolant transfers its heats to the feed water, and as a result of this, water are converted into steam. This steam enters into the steam turbine and used to rotate the turbine. The shaft of turbine is coupled with the shaft of generator, and hence electricity is produced. Okay. Then here are some advantages, disadvantages. Some applications are there. So you can see applications in solar water heating, solar pumping cells, solar furnace, solar cooking cells and all. So these are some advantages and disadvantages you can read out. Then what are these photovoltaic cells? If the question arises for one time, this question has arisen, so we should know about what are photovoltaic cells and what we can write in short for them. So these photovoltaics directly convert solar energy into electricity. They work on the principle of photovoltaic effect. When certain materials are exposed to light, they absorb photons and release free electrons. This phenomena is called photoelectric effect or photovoltaic effect. So this effect is a method of producing direct current electricity based on the principle of photoelectric power. You can see the diagram below, where photovoltaic, if this effect when we use or we place solar panels in our homes also. So this method is used in of photovoltaic energy. Okay, what is its construction we can mention. If such a question is asked, you can consider this topic also. In construction, you can say the semiconductor materials like arsenide, indium, cadmium, silicon, selenium, gallium, these all are used for making PV cells. Mostly we use silicon and selenium. Okay, now for considering this figure shows the constructions of the silicon photovoltaic cell. The upper surface of cell is made of thin layer of p-type material so that the light can easily enter into material. The metal rings are placed around p-type and n-type material, which acts as their positive and negative output terminals respectively. You can see in the diagram, n-type silicon and p-type silicon is present below. So here load is there, we will apply, if we apply the voltage, then we will get the electricity out of it. So anti-reflection coating is also there, then nickel plating, then you can consider this diagram. Okay, then what is its working? So the light incident on semiconductor material may be pass or reflected through it. So the PV cell is made of the semiconductor material, which is neither a complete conductor nor an insulator. This property of semiconductor material makes it more efficient for converting the light energy into electric energy. When the semiconductor material absorbs light, the electrons of the light material starts emitting, and this happens because of the photons consist small energy particles. So this is called as photons. Then when the electrons absorb the photons, they become energized and starts moving into the material. Because of the effect of an electric field, the particles move only in one direction and develops current. The semiconductor materials have the metallic electrodes through which the current goes out of it. This is not that much important topic, but still you have to remember, as this question have come in some paper at a time. Okay. Now we will come to wind energy. Yes, this is very easy one. So we can consider this wind energy as here you can see the diagram. What is wind energy? Now what happens here, basically wind energy is nothing but an indirect form of solar energy. When winds blow at high speed, those are made to be incident on the wind blades, as you can see in diagram. Due to the thrust action, blade tends to move, and when these blades are installed on a hub, you can see that blade hub above the supporting structure, it is as a result of traveling winds, hub starts rotating by the virtue of blade movement, and the rotating hub using gearbox is connected to alternator, which finally generates electricity. So here is this was nothing but the principle on which this wind energy power plant works. You can see in the diagram there are wind blades, then you have nacelle. What is nacelles work? You can see gearbox. Nacelle is not shown in the diagram, but you have to consider it as it is used for the filtration of wind. It is present on the tip of wind. Okay, then gearbox mechanism is used, and again I will consider yaw mechanism is also used. Input shaft, output shaft, generator, and all these things are present. Okay, so what has happened here? First of all, wind blades we will consider. So when blades face the direction of winds, when wind strikes on it, they tend to move by virtue of drag force. Then what is the purpose of blade hub? That square which is present above the supporting structure is nothing but the blade hub. In wind power plants, blade hub facilitates the installation of blades. When blades tend to move while winds are blowing, blade hub starts rotating. Okay, then input shaft is there. When blade hub is rotating, this rotational energy is transferred to gearbox using input shaft. Then output shaft, when speed of rotation of input shaft is increased, output shaft couples gearbox with the generator. Then a generator, its purpose we all know, it is used for conversion of electricity. Then gearbox, what is the work of gearbox here? As it is desired to change the speed of input shaft, a gearbox consisting of various meshing gears with different combinations of gear ratios is present, and this increased speed of rotation is provided to the output shaft. Then what is the working of nacelle? I have told you that when winds blow at high speed, it carries dust and other particles with it. Then for preventing all these particles from entering the system, nacelle acts as the covering to all the system. And what is wind vane? Wind vanes identify the speed and directions of wind. Then I have also used the word of yaw mechanism. What does it does? As it is needed that windmill should always face the direction of wind, when wind vane has identified the change in direction of wind, the blade hub is revolved in direction of wind, and using this yaw mechanism, that blades continue to face the direction of wind. So this was all about the wind energy power plant. I have explained you each and every constructional element and how does it works also. Then let us see what you have to write. See, this is the animation which I have shown you. The thing you can see that wind blows past turbines, then rotating their blades. Kinetic energy is transformed into mechanical energy. Then gearbox spins the generator to produce electricity. Alright, transformer converts electricity to appropriate voltage. Then electricity can then be stored or transported to the grid of distribution. This is how the wind energy power plant works. Then in introduction we can write that wind energy can be used for generation of electrical energy. It is renewable energy source. Then the wind power can generated where wind velocities are more than 8 kilometer per hour. Okay, in construction we can write it consists of blades. As wind strikes turbine blades, turbine blade rotates and produces kinetic energy. Then nacelle, gearbox, brakes. I have explained you each and every constructional element. Your platform or your mechanism, you can mention this also. Then advantages, disadvantages, we are familiar with this topic also, so I'll skip this, you can read it all. Then windmills are those machines that uses wind energy to produce electricity. All these things we all know. Now we have to consider two types of windmills, that is horizontal axis windmill and vertical axis windmill. Horizontal is the one which we are familiar about. I will show you. First of all, see this. This is wind turbine configuration. This is how the whole windmill is present. Like rotor diameter is there, rotor blades, gearbox, how generator and nacelle you can see here in this image. Nacelle is also present. Then tower is there, gearbox, how rotor blades are fixed. You can see. So this is about horizontal axis and vertical axis. You, if you are not getting this diagram easy, let us see the main thing. Here is the horizontal axis windmill, which you can see that this is the more familiar one. So this is about horizontal axis windmill. If you want to see vertical, then I'll show you after this. This is the theory for horizontal axis. I know this is very big, you don't have to write this much, just understand what horizontal axis wind turbines are do. These are the most common type used. Yes, we have seen them. So all of the components like blades, shaft, generator are on top of the tall tower, and the blades face into the wind. The shaft is horizontal to the ground. The wind hits the blades of turbine that are connected to shaft, causing rotation. The shaft has a gear on the end which turns a generator. The generator produces electricity and sends electricity into the power grid. Then wind turbine also has some key elements that adds to efficiency. Inside the nacelle is an anemometer, wind vane and controller that read the speed and direction of wind. As the wind changes direction, a motor or your motor turns the nacelle, so blades here turns the nacelle, so the blades are always facing the wind. The power source also comes with a safety feature. In case of extreme winds, the turbine has a brake that can slow the shaft speed, and this is to inhibit any damage to the turbine in extreme conditions. So I will say you, if horizontal such a question has arisen, then you have to write the whole explanation of a windmill which I have shown you before. The same thing is there, nothing changes. Now let us see what is vertical axis windmill. So this is the diagram for vertical axis windmill. Here all of the main components are close to the ground. In vertical axis turbines, the shaft, the blade are connected to vertical to the ground. Also the turbine itself is near the ground, unlike horizontal where everything is on a tower. There are two types of vertical axis turbines. Again, they are followed by lift based and drag based. So don't worry, we don't have to study these types of vertical axis. We just want to know that there are two types of windmills, that is horizontal axis windmill and vertical axis windmill. Now the next part of power plant is geothermal power plant. So what is geothermal power plant? Here geothermal energy is the form of heat energy which is available inside the earth's crust in the form of magma or lava, we can say. As this energy is available deep inside the earth's crust, it is called geothermal energy. Alright, so as very high temperatures are available at the crust, so this heat energy can be availed for converting it into electricity. Now, what would you can write in its introduction? The magma heats the water present inside the earth and increases its temperature greater than 182 degrees Celsius. Then, this hot water from the earth is pipping into the surface of the earth through hot water wells. The steam from the hot water is separated and mated to the strike on the turbine blade, and it starts rotating. A generator is coupled to turbine, also starts rotating and produces electricity. Then we have three types of geothermal power plants, that is dry steam, flash steam and binary cycle geothermal power plant. So we have to just know the basic parts. We don't have to go very deep inside these working and all. So this is a very small part for geothermal power plant. You can consider this diagram in which you can see that surface is there from which the dry steam is there, which is given to the filter, and that filter, from that filter it is impinged on the turbine, which is then coupled to generator, and then this steam is again given to the condenser, and that steam is then converted into water, and that through the pump is again given to the surface. So this is a very simple you can say the consideration for geothermal energy. Just the steam is taken and from the filter it is given to the turbine, so it is very easy to keep in mind. Then we have, this is the dry steam power plant, which you can consider for production well. From production well, steam is going inside the turbine, then the turbine is rotating, and as it is coupled to generator, electricity is produced. So like this is injection well from which the water is going inside the surface. Then this is all about dry steam power plant. Then we have binary cycle power plant. What happens in this binary cycle power plant? You can consider that in binary cycle power plant, the heat of hot water is transferred to another liquid. The heat of hot water is transferred to another liquid called a secondary liquid, and the heat of hot water causes another liquid to change into steam, and then this steam is used to rotate the turbine. It is most recent developed power plant which may be operated at the lowest temperature for at least 58 degrees Celsius. The secondary fluid, that is another fluid used in this binary cycle geothermal power plant, has much lower boiling point than water. The thermal efficiency of this power station is expected to be lying in between 10 to 13% only. This power plant is called binary since here we are using two liquids, hot water and secondary liquid, for its working. This doesn't comes for like main question, but you must have this knowledge of binary cycle. If such a question persists, you can write the answer. So this is how the binary cycle power plant work. You can see that hot water from underground is pumped through a heat exchanger which heats a second liquid that transforms into the steam. So this is nothing but the working of binary cycle power plant. So here is the construction of it. Then you can say that hydrothermal resources are used, and how dry steam is converted. Like if I show you here, dry or hot water wells are there. So these are the wells through which the dry steam or hot water from earth is taken out, and if dry steam is taken out, then it is called dry steam. See, if you have understood the diagram, I'll again say you can write its theory very well. So I am not wasting my time in just reading it out. You, if you have understood the diagram, just read this concept, you'll getting it very clear. Heat exchanger, then secondary binary liquid injection well, all these components are there and they're working. In short, I have written for you. Then it's working, I'll read out the working for you. The hot magma present inside earth heats the water present on the earth. Then the temperature of water increases up to 58 to 80 degrees Celsius. The hot high pressure water, due to its own pressure, moves upward in the hot water well as the water reaches to the surface of the earth. Its temperature increases, but it's not converted into steam. So that high temperature water is enters inside the heat exchanger. Similarly, at the same time, another liquid, isobutene, which has very low boiling point, is also enter in the heat exchanger. So the heat exchanger, there is an exchange of heat between hot water and isobutene takes place, and isobutene is produced. The steam produced in heat exchanger is allowed to strike on the blades of turbine. As this high pressure steam strikes the blades of turbine, it starts rotating. The generator coupled with the turbine also rotates and electricity is produced. So this is very deep working. I think you can write it in your own words simply, whatever. If you have understand the diagram, you can write its working, and it would be I think it would be easier than this one. So here all its binary cycle plants also diagram is given. You can consider it is same as that of the dry steam. Just here what is present, the hot water is impinged on the hot heat exchanger, and then simultaneously organic fluid is also there. So here this organic fluid and this hot water, they get accumulated, and then steam is produced, and that is given to turbine, and the same process. So this was about binary cycle plant. Then its advantages are there, like it requires no fuel, then it requires minimal land and fresh water, renewable energy source, harmful gases are not emitted, then capital cost is 40 to 60% less than thermal and nuclear plants, then short construction period is there. So these are all nothing but advantages. Disadvantages are also some, like fluid taken from deep contain mixture of gases. Yes, some gases I have mentioned. So these gases are released, it will contribute to global warming, of course. Acid rain, radiation, so this will be polluting. Then hot water taken out from the geothermal sources is held in a solution which may contain traces of toxic chemicals like mercury, boron, antimony and salt. So these, like we can mention, like this is polluting, as some gases are there which we emit in the environment. So this will pollute environment, and we can say it will increase global warming and all. So low efficiency, so such things you can mention in disadvantages. Then we come to tidal energy. So what is this tidal energy? It is because as we have considered high tide, low tide, right? So that is nothing, by using that high tide and low tide we can make out tidal energy also. So this is the introduction for it, like tidal energy, also known as tidal power, is a renewable form of hydropower where the kinetic or potential energy of tides are used for generation of electricity. Then a tide is created by the gravitational effect of sun and the moon on earth, as we all know how high tide and low tide occur. So because of the gravitational effect, thereby causing cyclical movement of seas leading to the tides. So here what happens, see here I have shown you the diagram for high tide, how high tide and low tide takes place. This is of a gravitational pull. Okay, then here is the diagram of intelligent nacelles, how it rotate to face the tide, and how it takes place inside the seas. These nacelles are placed inside the sea, and from this we generate electricity. So I have shown you the small animation of it, which is placed inside the seas or oceans, we can consider. So because of high tide and low tide, this will produce electricity. So how here it works? See, the sun and the rotation of earth both have some tidal impact. The location of moon has biggest effect on the tide. The gravity of moon causes a high tide both on the side of earth directly below the moon and the opposite side of earth. So low tides are on the sides of earth 90 degrees away from the moon. You can see this diagram. Here high water level is there, and as high tide is persisting, if this turbine tunnel, as I have shown you in the previous animation, how does it is situated. So that turbine rotates, and here towards the head height where it is low, the water is impinged over here. So as the turbine is rotating, the main thing will get electricity by the generator. So this is how the tidal energy power plant works. You can consider its constructions like a tidal barrage, sluice gates, turbine, generator. So you can see this in the previous diagram also. What are its function? I'll read out for you. Tidal barrage is used to hold the water back during high tide. A function of barrage is to form barrier between sea and basin. Then sluice gates are there. The sluice gate opens during high tide and close during low tide. This creates the water level difference. Then tidal turbine, high pressure water strikes on turbine, because of the shaft of turbine rotates. Then generator, its work we all know. Okay, then what is its working? See, during high tide how it works, and during low tide how it works. So during high tide period, the level of the tide is more than the level of water in the tidal basin. As a result of this, water flows from the sea to a tidal basin, and this operates the turbine and ultimately generator. Hence electricity is produced. Simply the high level is coming to the low level, okay, water. So through that effect only we are making profit, and we are making electricity from it. And during the low tide period, the level of tide is lower than the level of water in tidal basin. As a result of this, water flows from tidal basin to the sea, and this operates the turbine and ultimately generator. Hence electricity is produced. So this is how high tide, and with the help of high tide and low tide we can make electricity. Here is the working of tidal barrage. You can understand by this diagram how the tidal basin works. Okay, here is the ocean. Here you can see the turbine is situated, then sluice gates are then barrage and all. So how that from a high level to the low level water is flowing, and because of that the turbine rotates and we will get the electricity out of it. What are its advantages? You can read out these advantages and disadvantages. Here are the disadvantages. Then let us come to hydrogen energy. Okay, this hydrogen energy power plant, not power plant we can say, but this hydrogen energy is not having that much disadvantages, so we can consider it as an environment friendly one. So hydrogen is a very light gas. Its density is 8 times less than that of natural gas. There are no significant problems with regard to storage, transportation. Advantages of hydrogen: as it is easy storage, so a large volume of hydrogen can be easily stored. Then it has high efficiency. Then it is pollution free. Then we have various applications, like it is used for transportation, heating and power generation in places where it is difficult to use electricity. Economically also it is less costly. Then let us see what are disadvantages of it. Here, while widely available, hydrogen is expensive. Yes, it is difficult to store. Then hydrogen is very hard to move around, and it is not easy to replace exciting infrastructure, and it is dependent on the fossil fuels. And this is the diagram for hydrogen fuel cell. You can consider we give a fuel like hydrogen from one side and we give oxygen from the other side, and in between what happen, electrons flow take place, and we all know what is the flow of electron is nothing but electricity, and as the result hydrogen and oxygen mix and we'll get water as the byproduct. So this is how electricity is produced by using hydrogen fuel cell. So here is its working, and this diagram you can consider for writing or drawing an exam. Here a fuel cell is an electrochemical cell that converts the chemical energy of a fuel and an oxidizing agent into electricity. Fuel cells can produce electricity continuously for as long as fuel and oxygen are supplied. You can consider, wait a minute, watch what is this inside the diagram, you'll get to know about it. So here is how the animation I put for a fuel cell. You can see here hydrogen is supplied, then oxygen is supplied, and because of heat, these electrons flow takes place, and that's how the electricity is produced. Here is the construction of it: anode, cathode, electrolyte, catalyst. You can read out this. It is very simple. As anode, we all know positive part, a cathode negative. Electrolyte is the proton exchange membrane. Then how it conducts this ion. Then catalyst. So this all you can read and understand. It's working. I have told you. Just read. You'll get into it. This reaction takes place. Remember this reaction: oxygen plus hydrogen plus electrons give water. Then at cathode this reaction takes place. At anode hydrogen gives hydrogen positive plus 4 electrons, and overall reaction hydrogen plus oxygen gives water. Okay, these are the advantages, disadvantages. So this is not a very important question, but you can consider it, read it. So if it comes in exams, you'll be writing everything for it. You'll not be sitting blank for that. Okay, here are the applications. What are the applications? These power devices like hearing aids, video recorders, then cellular phones and laptop computers. Source of power to cities, towns and buildings, used to back up remote power applications including remote weather stations and rural locations. So these are the applications. Now let us come to biomass energy, in which you can consider that biomass is a fuel that is developed from organic material, a renewable and sustainable source of energy used to create electricity or other forms of power. There are some sources like leaves of plant, agricultural, biomass, we can say biofuels, then biogases, solid, liquid gas, like this you can consider for it. So from leaves of plant, from agricultural waste, how this biomass energy is obtained, you can just read and you will get it now. Like in densely planted places, lots of leaves fall from the trees. This can be dried, powdered and converted into the small piece which can be used as the biomass fuel. Then agricultural waste, in this lots of waste material is there. So from this also we can get, or we can generate methane gas. Like this biomass energy can be generated from food and waste wood also, then waste paper also. So you can read this, you will get this knowledge. This knowledge we know prior also, but just for writing how biomass energy is obtained, we need to mention this some topics. Here garbage, then human waste. Then this is the biogas plant. You all know, we have studied this. So in this fixed dome type biogas plant is there, in which underground digested tank is present. Here you can see whatever slurry of cattle dung and water is there, they are mixed and they are given inside the dome shaped plant, and from this what happens, outlet gas is produced inside, methane gas is produced, and from the outlet chamber it is given out. Here are some biofuels. Now as we saw what are how biomass is obtained, like from garbage, from solid waste. Biofuels we can see jatropha oil and then ethanol. These all things are biofuels. These fuels are produced directly or indirectly from organic material. What are its advantages? Are like they are produced from renewable energy source. There is less pollutant as emissions are less. Like this, and advantages you can mention. Disadvantages like it's not completely clean. Then possible deforestation, high cost in comparison to other. Then space requirement is there. It requires water. Inefficiencies. It's under development. So these all things we can consider. What are applications? So these biomass systems range for all small stoves used in homes for heating or cooking, as we all see in villages and all. This technique is only used for cooking and all. In residential applications, biomass can be used for space heating, for cooking. Wood is the most common source of fuel, although many different materials are used. New designs for wood stoves can improve the efficiency of cooking, heating system, decreasing the amount of fuel that is needed. Then some energy conversion devices. Now yes, we have completed the first part of this chapter. Now we are going to second part of the chapter. This is very simple and short. We'll complete it in a short time. Just we have to see these things like centrifugal pump, reciprocating compressor, Pelton turbine, wind mill. Yes, we have used these components, but this conversion device separately come in our exams, and we have to explain them. So how we can explain them, let us see. First we will start with the pump. Pump is a device which transfers the input mechanical energy of motor or of an engine into pressure energy or kinetic energy, or both of fluid. Then this is a device which converts mechanical energy into hydraulic energy of fluid. It is classified into like two: reciprocating pump and centrifugal pump. You have to write the difference between reciprocating and centrifugal pump, as reciprocating is also called positive displacement pump. And you can see, like for example, in reciprocating pump you can write its working as of it is very simple and just like an IC engine. Then if the piston is of the single acting type, which means it can suck from one side and transmit to the same side only. Then centrifugal pump, it is a device or equipment which converts kinetic energy to pressure energy by rotating impeller. The fluid flows from inlet to the suction eye or the impeller center and out along the vanes. The kinetic energy from the rotating impeller is transferred to the water in the form of its pressure energy, thus increases the pressure head. You can, if you, I'll show you the diagram, then you will be better understanding the difference between reciprocating and centrifugal pump. Here, this is the flowchart which is showing the classification of pumps: dynamic pressure pumps and positive displacement pumps. See, this is the flowchart. You can see it just for knowledge. We have to consider reciprocating and circulating pump. So, just see for while like dynamic pressure pumps and positive displacement pump, these are the two types of pump in which we are going to see reciprocating pump. So, let's go ahead. Here is the centrifugal pump. See the animation, you will be better understanding like how water is moving and how the water is moving outside the outlet. So this is how the centrifugal pump works. Discharge is there, then volute casing you can consider, impeller is present, and how this discharge takes place. So this is the complete diagram for centrifugal pump. Then let us see its introduction. How centrifugal pump, it is the hydraulic in the mechanical energy and it convert into pressure. Then construction in impeller is the very most part of important part of pump. Why? Because it is the rotating part of the centrifugal pump. It consists of curved vanes. Then casing is required for airtight passage surrounding the impeller. The casing is of spiral type in which the area of flow increases gradually, and this increased area and increased pressure of water flowing through the casing. So just you have to write about what you all know about that construction element. Suction pipe, you all know, it is one end which is connected to inlet of pump and other end dips into the water pump. Then at the lower end of suction pipe, a strainer is fitted to remove dust and dirt. Delivery pipe, it delivers the outlet of the pump. Then how it works? So the water from the pump is forced on the shaft and the water falls on the impeller, which consists of a curved vanes. Because of the rotating curved vanes, water is discharged with the high pressure, and guide vanes are used to guide water to delivery pipe. We all know why pumps are used. They are used to take water from lower passage to higher passage, right? So this is the diagram for, you can see how the pumps work usually. Then this is also the working of centrifugal pump, how it takes water from the sump, and a suction pipe is there. Then suction flange, how the impeller rotates and the overhead water tanks gets the water from the outlet delivery pipe. So this is how the water from lower head is given to the upper head. Then these are types of turbines which we can see here. Different types of turbines are used. So these are some images. Then some disadvantages are there for pump, like it is a small in size, then capital cost is less, it is easy in maintenance, it deals with large volume, it is able to work medium to low head and works with the medium to low viscous fluid. Disadvantages, its bearing damages due to overheating, it doesn't allow shaft misalignment, its seals bearings need to be replaced from time to time and requires priming. So when this question of pump, like explain pump, arises, you have to write what is pump, then you have to mention these two types, centrifugal and reciprocating pump. Write short about them. If you know the diagram as I have shown you about the centrifugal pump, you can mention that it is very simple diagram, and you can show where impeller, when all suction pipe, then delivery pipe, these all are present. Then just explain how water is transported from low head to the higher head, and then mention these advantages and disadvantages. You will be completed with the answer. Then what are its application, also you can write for pumping of sewage slurries and all. So you all know what are the applications of pumps, so you can read this or you can write in your own words also. Then we have this reciprocating pump. We have studied about centrifugal pump. Now let us see what is this reciprocating pump. So this, it works like this. Here you can see the connecting rod is there, crankshaft, then how it is suction is taking place from below and discharge is taking place from the outside. So like this, from lower head to high head, this discharge of water takes place through reciprocating pump. You can see like a reciprocating pump is positive displacement type of work. In this, liquid is displaced using piston cylinder arrangement, which is driven using crank and connecting rod. You can explain about suction pipe, delivery pipe, then piston and cylinder arrangement. All right, crank and connecting rod, you can explain this, it is same about as of centrifugal only, just the diagram changes and some of its properties changes. So your working is there about suction stroke and these things you can write, you can read about delivery stroke and all. Then air compressors, we will come about air compressors. These are the second type. We have studied about pump. Now let us come to compressors. Here it is a device or a machine providing air at high pressure. It is called as air compressor. An air compressor, atmosphere air is compressed and delivers high pressure air to storage vessel known as receiver. See, if you consider supercharging of IC engines, spray paintings and all, the pressurized air is a pump inside, like, so that is nothing but the compressor, and it is used in all of these applications I have mentioned here, like machine tools, conditioning, diesel engine, air breakers, spray paintings, refrigeration, air conditioners. So these are all applications of air compressors. How it is classified? It is classified on the type of motion, then according to number of stages, then according to working position of piston, according to discharge. You can skip some of this, like for example you can write about the type of motions only, like it is divided into two types of motions, reciprocating and rotary. You can mention about the according to discharge pressure, like low, medium and high. It is not compulsory for writing all the classifications, but if you do, it is very I'll say it is great. Then for introduction you can write, this is the single step, single acting, reciprocating, compressor, crank and connecting rod, inlet and exhaust. So these are all constructional elements. Working, you can write, it is divided into two stroke and like in suction stroke and delivery stroke, these two strokes are present as we have seen in centrifugal pump. You can read these things, not necessary to write them such a great detail. If you have asked, just write the basic about what you all know about centrifugal and reciprocating pump. Then if you write the constructional elements, it is very good in that. Then this compressor is again divided into two, like positive displacement, dynamic one. Then here reciprocating, rotary and centrifugal, axial. Like this reciprocating is again classified into single acting, double acting and diaphragm. Rotary is again divided into three, lobe, screw and vane, liquid, ring and scroll. Five types. Then dynamic is centrifugal and axial. This is not important, just remember it is divided into two types, positive displacement and dynamic one. Then compressor, as it is single acting, single stage reciprocating air compressor, there are again reciprocating compressor. So here in its classification, okay, in reciprocating air compressors, positive displacement machines are there, meaning that they increase the pressure of air by reducing its volume. This means they are taking in successive volumes of air which is confined within a closed space and elevating this air to a higher pressure. Reciprocating air compressor is a single acting when the compressing is accomplished using only one side of piston, and a compressor using both sides of piston is considered double acting. So this is the diagram for reciprocating air compressor. Any of the one you can draw in your exams. Okay, you can write, you can see like delivery valve is closed, then here inlet valve is open, air is going inside from here, and the piston cylinder assembly is there, in which connecting rod is present and crank wave which keeps on moving, and here crank case is there. Okay, then here you can see the animation of reciprocating air compressor. How does it works? See, like this. I hope you are getting clear. Here are the applications: power tools such as air hammers, drills, wrenches and others. Compressed air is used to atomize paint, to operate air cylinders for automation, to propel vehicles. So some of the applications you also can write. And here is the turbines part. Now we have considered turbine in our previous power plants, but what actually turbine is, if such a separate question is asked, you can write this. Turbine is a hydraulic machine which converts hydraulic into mechanical, then mechanical energy of turbine further converted into electrical energy. The classification of turbine is there according to head and quantity of water. We have impulse and reaction turbine. In impulse, what is there? Turbine requires high head and less quantity of water flow, and in reaction turbine requires low head and high rate of water flow. So this is the difference in impulse and reaction. Then according to the name of inventor also, some turbines are present like Pelton turbine, Francis turbine, Kaplan turbine. So these are also named on the inventor. So they also have different properties but are the turbines only. Just remember that impulse, reaction turbine, and then Pelton, Francis, Kaplan, these are the main types of turbine used. Pelton turbine is there, which you can see it is a type of a tangential flow impulse turbine used to generate electricity in hydroelectric power plant. In hydroelectric power plant, we use this type of Pelton turbine, and the energy available at the inlet of Pelton turbine is only kinetic energy. The pressure at the inlet and outlet of the turbine is atmospheric pressure. You can see in the diagram, the wheel is impinging from the lower side. Alright, here this Pelton turbine, I have made the shot also, and it is uploaded on my channel. You can see how the water is impinging on it, and then the turbine rotates. This is about the turbine. Here you can see the animation how the water is flowing and the turbine rotates, and as turbine is coupled to generator, we will get the electricity. How its construction is there, you don't have to write this much construction, just read out, and whatever you remember from these points you write in exam. So here is nozzle and flow regulating arrangement. This turbine is very simple concept. You can, if you have understood in power plants itself, you can write its description very easily. Just understand about its types and all if it is there. Then nozzle and flow regulating arrangement is there, in which nozzle is used to increase the kinetic energy, we all know. So if you know that what is the purpose of nozzle, you can write its description. Then runner and buckets are used inside the turbines. Then we have casing. What is casing? It is outer covering of the turbine. Then it prevents from splashing of water. Then helps to discharge the water. So this all you can write. Then braking jet is also there. When the jet of water is completely closed by pushing the spear in forward direction, then the amount of water striking the runner becomes zero. Like this, what are its working? Just read out once, you will get to know about the concept. I have written in very simple language. You will be understanding it. What are its advantages? As it is less space requirement for turbine, then blade manufacturing is simple, steam velocity is higher, less pressure drop. Disadvantage is like it is less efficient and suitable for small power requirement. You will be better understanding this concept. I'll say again, if you see my shot of Pelton turbine, there you can see how water is impinged inside the turbine and it rotates, and hence it is connected to generator, will get electricity. So it is a very small construction, but how electricity is produced from that construction we'll know. So this was our one unit, that is introduction to energy sources. I know it was very big, but I have tried to complete it in one shot. Some of the topics I have left just not reading them. If you go through the video again, just understand the main diagrams while revising also. If you are done with this chapter in your college also, just to see the video, you will be understanding each and every concept. I have put in animations also, so for that only. If you have understood small thing also from this video, then please hit the like button and do subscribe to my channel. And till the time, thanks for watching and keep studying.